Hi, in this video, we are going to talk about complex numbers. So we know that the square root of real number is always non-negative. For example, 4 square is equal to positive 16. Negative 4 square is equal to positive 16. Therefore, the square root of positive 16 is plus minus 4. Now, what about the square root of a negative number? It is clear that a negative number cannot have a real square root. So we need to extend the system of real numbers into a system in which we can find out the square root of negative numbers. So Euler was the first mathematician to introduce the symbol I for positive square root of -1. Okay, so by definition, a complex number denoted by letter Z is an ordered pair of real numbers x and y. Okay, written as, the complex number Z equals xy. Okay, where x is called the real part and y is the imaginary part of the complex number Z. Okay, so you may be seeing this notation. So when you say REZ, it means the real part of the complex number Z. And in this case, x is the real part of the complex number. And INZ means the imaginary part of the complex number Z, denoted by letter Y. So for the ordered pair 0, 1, so this is an imaginary unit and denoted by the letter I, where you can see that the value of x here is 0, meaning the real part is 0, and the imaginary part is 1. So this is denoted by the letter I. Okay, in practice, complex numbers are written in this form: Z equals x plus I y. Okay, or Z equals x plus yi. For example, 17 plus 4i. So instead of writing I4, since we have already a real number or a constant present in this form of complex numbers. Okay, so if x is equal to 0, then the complex number Z is equal to IY. And this is a pure imaginary complex number since you have no real part in this form of complex number. Okay, and I squared is equal to -1 because by definition of multiplication, say I squared is equal to I times I. And by, using the coordinate form 0, 1, 0, 1, it resulted to -1, 0. The value of I squared is equal to -1. So just imagine multiplying square root of -1 by square root of -1. So maka-cancel yung square root. So that's why we have -1 here. Now the square root of a negative number is called an imaginary number. For example, so square root of -9. So if you factor this, we have square root of -1 times the square root of +9. So you know that the square root of -1 is I, and the square root of 9 is 3. So we can write 3i as the answer to square root of the negative number, okay, -9 in this case. Another example, square root of -7 is equal to the product square root of -1 times square root of 7. Square root of -1 is equal to I. Okay, so we write I square root of 7 will be the answer to this. Okay, please note that every real number is a complex number with 0 as its imaginary part. Okay, so every real number is a complex number with 0 as its imaginary part. Now let's move on to the successive integral powers of the imaginary unit or imaginary number. So so we have the value I equal to square root of -1, but in this case, so that we will see, the pattern. So we write I equal to I squared being the product of I times I is equal to -1. I cubed is equal to I squared times I, where I squared is equal to -1. So -1 times I is equal to -I. I raised to 4 can be factored to I squared raised to 2. So I squared is equal to -1. So -1 square is equal to +1. Now, I raised to 5 is equal to I raised to 4 times I, and you know that I raised to 4 is equal to positive 1. So 1 times I is equal to I. I raised to 6 is equal to I raised to 4 times I squared, and I raised to 4 is 1. I squared is negative 1. So 1 times negative 1, we have negative 1 is the answer to this. I raised to 7 is equal to I raised to 4 times I raised to 3. I raised to 4 is 1. I raised to 3 is negative I. So multiplying, it will result to negative I. I raised to 8 is equal to I raised to 4 squared. So I raised to 4 is 1. 1 squared is equal to positive 1. So what have you noticed? It's alternating. So you have I, negative 1, negative I, 1. I, negative 1, negative I, 1. So we can actually have this formula in finding for or evaluating, I with a given power. Of course, you can use your calculator to verify it, but there are, restrictions or limits for it. So numbers or powers like 1000 cannot be, seen in your calculator if you are to evaluate. So let's have this formula. So I raised to 4n plus 1 is equal to I. So it means that I with a power divisible by 4 plus 1. So the answer will be I. Next is I with a power divisible by 4 plus 2 is equal to negative 1. So I with a power divisible by 4 plus 3 to the exponent is equal to negative I. And finally, I raised to 4n plus 4 is equal to 1. Okay, let's have an example for this. Okay, say for instance, we have I raised to 30. Is 30 divisible by 4? 30 divided by 4. If it's a whole number, then the number is divisible by 4. But since it's not whole number, so 30 divided by 4 is basically 7.5, right? So it's not a whole number. So what is the closest number to 30 that is divisible by 4? That's my question. And we know that the closest number divisible by 4 is 28, right? So yeah, check mo. 28 divided by 4 is equal to 7. So we say I raised to 28 plus 2. So this is just equal to I raised to 30. Or this can be written as I raised to 28 times, of course, I squared. And we know that I raised to a power divisible by 4 is equal to 1. So this is 1. And I squared is equal to negative 1. So this illustration actually shows us the second formula. So I raised to a power divisible by 4 plus 2. So the answer is negative 1. Now, how about these examples? So I raised to 21. So the power 21 is not divisible by 4, but the closest number to 21 that is divisible by 4 is 20. So this given actually is I raised to 20 plus 1. So plus 1. So it qualifies to the first formula. So the answer to letter A is I. Now for letter B, I raised to 2016. If you are to divide 2016 by 4, so it's actually a whole number, then letter B is, the answer to this is positive 1 since 2016 is divisible by 4. So any number divisible by, or any, if you are to evaluate, an imaginary unit with a power divisible by 4, the answer to that is 1. So a number divisible by 4, I raised to a number divisible by 4 plus 3 is negative I. Divisible by 4 plus 2 is negative 1. And if it's plus 1, it's I. Okay, so if you have any questions, so just comment down below. Okay, or message me via MS Teams. Now let's go to the product of complex numbers and its conjugate. So a complex number is denoted again by letter Z. Then the conjugate is denoted by this letter with a bar, on top of it. So Z times Z bar, okay? complex number multiplied to its conjugate. The answer to this actually is the sum of the squares of the real numbers. So x squared plus y squared. So maybe I can, show you how it resulted to x squared plus y squared. Okay, so we just follow the FOIL method in doing that. So FOIL, so first terms, x times x, so you have x squared. Okay, outside terms, x times negative iy, so you have negative I x times y. So inside terms, so that is positive I x times y. And the last terms, so positive times negative, so you have negative I times I squared, y times y, so you have y squared. So this is just, to show you that that the product of a complex number multiplied to its conjugate is equal to the sum of the squares. Now we can see from here that they are like terms but different signs, so we can cancel this one. So the result is x squared. So negative, and you know that I squared is equal to -1. That's why we have x squared. Okay, negative times negative is positive. Yeah, so multiplying a complex number by its conjugate. So when we say conjugate, the sign of the imaginary part changes. So from positive, naging negative siya. Okay, clear tayo dun? So that's it. If you multiply a complex number by its conjugate, it will result to the sum of the squares of the real numbers, x squared plus y squared. Now let's move on to the next theorem. Number one, if x plus iy is equal to 0, remember, a complex number is equated to 0, then x is equal to 0, or the real part is equal to 0, and y, the imaginary part, is equal to 0. Number two, if x sub 1 plus I times y sub 1 is equal to another complex number, x sub 2 plus I times y sub 2, then the real numbers are equal. So x sub 1 is equal to x sub 2, and y sub 1 is equal to y sub 2. Okay, for instance, so we have this equation, x minus 2 plus 4yi is equal to 3 plus 12i. So as you can see in the left-hand side of this equation, x minus 2 is the real part, so it's equated to the real part of the right-hand side of the equation. So we have x minus 2 is equal to 3. And for the imaginary parts, we have 4y is equal to 12. If you divide both sides by 4, that's why we have y is equal to 12 divided by 4 is equal to 3. Now, the third theorem is if x sub 1 plus I times y sub 1 is multiplied to x sub 2 plus I times y sub 2 equated to 0, then we can say that x sub 1 plus I times y sub 1 is equal to 0, or x sub 2 plus I times y sub 2 is equal to 0. Now let's have another example, real values of complex numbers. So find the real values of x and y in equation 2x plus I 4y minus 3 equals I times 3x minus y minus 10i. Okay, so this is an equation we can apply the theorem in the previous slide. So what you will do here is to transpose everything to the left-hand side and then combine all the real parts and combine all the imaginary parts. So it means that the equation will now be equated to 0. Now this is the arrange or the equation that resulted to after we transpose the right member of the equation to the left side of the equation. So everything that you transfer to the left-hand side will now change its sign. So just like this, positive I3x will become negative I3x. A negative y will become positive y, and negative 10i will become positive 10i. So what I did here is I grouped, or we combine all the real parts. So we have 2x, we have positive y and minus 3 as the real part, And those with I or imaginary unit in that term will be in the imaginary part of this equation. So we have 4y, this becomes negative 3x, and then you have minus 10 becomes positive 10 because you are transposed from right to left. And then we equate to 0. Now, remember in the theorem, number 1, if the complex number is equated to 0, then we can say that the real part is equal to 0. In this case, 2x plus y minus 3 will be our equation 1. And of course, the imaginary part will be equal to 0 also. So in this case, we arrange it so that it will be, it will have the same variable on the first term with the first equation. Okay, so we did this for us to be able to determine the value of x and y. So you can use your calculator, two equations, two unknowns to determine the value of x and y. Or simply, you can eliminate, or you do elimination by substitution to determine the value of x and y. So let's try this one. So what I will do here is I'm going to eliminate, okay, y, and then solve for x. So I'll be multiplying negative 4 in equation number 1, and then add equation 1 and 2. So multiplying the entire equation 1 by negative 4, this will become negative 8x. This becomes minus 4y. And this becomes positive 12. Okay, so again, you can use your calculator, guys, to solve for the value of x and y. So now we copy, okay, equation 2, since we are going to add. So minus 3x plus 4y plus 10. So I'm going to show you how to determine x. So the next variable will be up to you to solve. So just substitute the value of x to solve for y. Okay, now, so we do this. We multiply negative 4 to eliminate, the term with y. So negative 8x minus negative 3x is equal to negative 11x. Negative 4 plus 4, okay, so 0. 12 plus 10 is 22, okay, equal to 0. Or yeah, transpose this to the other side of the equation so that we have positive 11x. So the answer to this will become, if you transpose this, it will become positive. So 11 will be our denominator here. And then, of course, you have 22 on your numerator. So 22 divided by 11 is equal to 2. So the value of x is 2, and then you substitute. So use equation 1 to solve for y. And then, of course, so you will be having, sige, sulat na lang natin. So using equation 1, so 2 times 2 plus y, okay, minus 3 equal to 0. So we have y equals, okay, this will become, if you transpose to the right-hand side, you have negative becomes positive 3, negative 3 becomes positive 3, and then this will become negative 4. So the answer to this is negative 1. So x is equal to positive 2 and y is equal to negative 1. So these are the real values of x and y. Okay, so that's it. Now let's go to the different forms of complex numbers. So, but we start with the standard form of the complex number. So the standard form or the rectangular form is written as z equal to x plus iy. So this is the rectangular or standard form of the complex number, wherein x is the real part and the second term is the imaginary part. So the one with an I or imaginary unit in its term. Now we have the following, how to do addition, subtraction, multiplication, and division using complex numbers in rectangular form. So this is how you do it. So if you add two complex numbers in rectangular or standard form, so you simply combine the real parts in this case, so x sub 1 plus y, x sub 1 plus x sub 2, and combine the imaginary parts. So this is the imaginary parts of the two complex numbers being added. So y sub 1 plus y sub 2 multiplied to I. So this is how you determine the sum of the complex numbers, okay? And the same idea for subtraction. Okay, so like terms. Now we subtract the like terms, so x sub 1 minus x sub 2, and then plus, the difference of the imaginary parts, y sub 1 minus y sub 2. Okay, and now for the multiplication of complex numbers in standard form. Okay, so what we will do is, we follow the FOIL method, or simply we do this. So the difference of the products of the real parts and imaginary parts. So x sub 1 times x sub 2 minus, so you have here y sub 1. Let me just change the color of, okay, laser pointer. Yeah, y sub 1 times y sub 2. So this is the real part of the resulting, or the product of these complex numbers. Now for the imaginary part of the product, so we have using full method, okay, so x sub 2 times y sub 1, okay, plus y sub 2 times x sub 1. So it's just alternate. So this is the result of multiplying two complex numbers. Okay, now let's go to division of complex number. Now, for the division of complex numbers, okay, so this is, the formula that you can use, or the practical rule actually is that you don't divide here. So we multiply the conjugate of the denominator. Okay, for example, if we have this complex number, okay, z sub 1 divided by z sub 2, and z sub 1 is equal to x sub 1 plus I y sub 1, and z sub 2 is equal to x sub 2 plus I y sub 2. So you actually multiply the numerator and the denominator by the conjugate of the denominator. So the conjugate of x sub 2 plus I y sub 2 is, so simply you change the sign of the imaginary part. That's how you write the conjugate. Okay, so x sub 2 plus I y sub 2 multiplied to x sub 2 minus I y sub 2. So kung ano yung multiply mo sa denominator, yun din yung sa numerator. It's as if that you introduced 1 in the quotient of, z sub 1 and z sub 2. Okay, so by, using FOIL method for the numerator, we have, okay, x sub 1 times x sub 2. So you have this, and then plus y sub 1 times y sub 2. So this is the result for, the real part divided by, since if we are to multiply, complex numbers, or complex number by its conjugate, it will result to the sum of the squares. So in this case, x sub 2 square plus y sub 2 square. Okay, plus. Okay, here in your imaginary part, so you have x sub 2 y sub 1 minus x sub 2 times y sub 1. Okay, so if you can see in the FOIL method, so this is the part where you have in the imaginary unit, and this will be negative I y sub 2 multiplied to x sub 1. That's why you have a difference here in the imaginary part of the formula. So this is the real part, or represented by x, and this is the imaginary part represented by y. So you can use this formula to determine the division of complex numbers. If you forgot this formula, you can just, multiply the quotient by, the conjugate of the denominator, multiply the numerator and denominator by the conjugate of the denominator, the given complex number. Okay, again, if you have questions, so please comment down below, or you can simply message me via MS Teams. So let's have an example here, a very simple example. Add and subtract the numbers 3 plus 4i and 2 minus 7i. So This is the solution. Okay, if you add complex numbers in rectangular form, so you simply combine the real parts. In this case, so 3 plus 2, okay, and combine the imaginary parts. So you just add, okay, plus I times, so this becomes 4 minus 7, and the result is 5 for the real part, and then minus 3i for the imaginary part. So this is now the sum of two complex numbers. Now for the other operation for subtraction, so you just, get the difference of the complex number of the real parts and the imaginary parts. In this case, so 3 minus 2, that is 1, and then 4 minus, okay, negative 7, so it will become plus. That's why you have 11 in your answer. Okay, 11i. Another example is finding the product of the complex numbers, the same given. So how do you perform? So you can use the FOIL method. So you basically add, the product of the real parts. I mean, you add the product of the real numbers. So 3 times 2 is 6, 4 times 7 is 28. Okay, and then you add them. So 6 plus 28 is 34. So itong nasa first line, yun yung sa FOIL method. Okay, pero ito nirekta ko na. And then, how about for the imaginary parts? So yung imaginary parts, so ano lang sila? Mag-cross lang sila. So i-add mo sila. So 4 times 2 is 8. And then you combine that with the product of 3 and negative 7. So 3 times negative 7 is negative 21. Negative 21 plus 8. The answer is negative 13i. Okay, so the result for this is 34 minus 13i. And finally, for the division of these complex numbers, you divide 3 plus 4i by 2 minus 7i. So what we will do here is to multiply this or quotient by, of course, the conjugate of the given complex number. In this case, so this is 2 minus 7i. So you multiply the numerator by 2 plus 7i. The same with the denominator 2 plus 7i. So the idea here is that if you multiply the complex number by its conjugate, the denominator for this one will be the sum of the squares. So 2 squared is 4, 7 squared is 49. Okay, so real number or real part yung nasa denominator. Okay, so you just do the FOIL method, or in this case, so 3 times 2 is 6, and then 4 times 7, you subtract them. So 4 times 7 is 28. So 6 minus 28 is negative 22. So that's for the first term of the real part dun sa numerator. And then, i-add natin yung product, diba? So 4 times 2 is 8. Okay, tandaan lang 4 times 2 is 8. 3 times 7 is, tandaan 4 times 2 is 8 plus 3 times 7 is 21. 21 plus 8 is positive 29. Tapos lagay mo na lang yung I. And then, you divide each term by 53. Itong sum of the squares of the real numbers. So negative 22 over 53 plus 29 over 53i. So if you can still simplify this, or in other cases, like, you must write your simplified answer. Okay, now let's go to the complex plane before you start your seat work. Complex plane is the representation of complex numbers in the XY plane, or we call this the Argand diagram. So named after the French mathematician Jean Robert Argand. Okay, so this is the complex plane. Remember that we have, x as the real part in the complex number and y as the imaginary part in the complex number in rectangular form. So therefore, in the complex plane, x is the real axis, or the horizontal axis is the real axis, and the vertical axis is the imaginary axis. Okay, let me give you another illustration for this. Let me just get a pen so that I can show you an example, to represent the complex number in the complex plane. Okay, say for instance, I have 2 plus 3i. Okay, remember that 2 is the real part and 3i, or this term, is the imaginary part. So in the complex plane, this is how you write. This is the x-axis or the real axis. This is the y-axis or the imaginary axis. So we have 2, 1, 2, and then for y, I have 3, 1, 2, 3. So the point here, okay, this is, how you represent this complex number. Okay? Rectangular form siya kasi, yan, ganun lang yun. Now, if negative naman ito, so if you have negative, for example, negative 2 plus 3i, okay, yung negative 2 is nasa left side ng complex plane mo, so plus, yan. Ito kasi plus 2, positive 2 yan. Ito naman negative na part, so negative 2. So the same lang yung y, so ito na yung complex number natin. Now, for the conjugate of this complex number, magiging negative 2, di ba? So dito lang yan sa baba. Negative 3, magiging ano siya? 2 minus 3i. So negative 3 yung nasa baba. Okay, so positive 2 yung real part. Ganun lang. Okay, that's how you represent the complex number in rectangular form. This is a complex plane or the Argand diagram. Now let's go to the next page. Okay, the complex conjugates I have just shown you earlier. So remember that a complex number is denoted by letter Z. Of course, the conjugate will be represented by Z bar. Okay, so this is the conjugate. You just change the sign of the imaginary part. So if it's positive, the conjugate will be negative IY. Maging negative yung imaginary part niya. Okay, showing you the complex numbers in the complex plane. So in complex number na 5 plus 2i is being represented here in the complex plane, and its conjugate, yan, kanina pinakita ko na yun in the previous slide. Okay, or simply, okay, remember these formulas. You might be seeing this. REZ means the real part of the complex number Z, or denoted by X. Or simply, you can do this by, 1/2 of the sum of the complex number and its conjugate. So this is very useful, lalo na kapag you'll be dealing now with, you are to evaluate or to prove something, using letters na yung mga involved, hindi na yung mga numbers. So, ganun lang din naman. So, Z plus Z bar. So, mangyayari, maka-cancel lang yung imaginary part. So, in this case, 5 plus 5 is 10. 10 divided by 2 is 5. So, X is equal to 5 actually. And the imaginary part of the complex number Z is denoted by Y. So, to determine that, di ba yung sagot dito is positive 2, right? Get the difference and divide by 2i. So, Z is equal to what? 5 plus 2i, i-minus mo dun sa 5 minus 2i. So that will become 5 minus 5, makancel yung real part. Tapos yung imaginary parts naman. So 2i plus 2i, magiging 4i siya. So 4i divided by 2i will be positive 2. So yun na yun. Now for your SEATWORK, okay, so you have two complex numbers, Z sub 1 and Z sub 2. And you are to find the following. So number 1, so product of Z sub 1 and Z sub 2, tapos you get the conjugate. Okay, multiply first the complex numbers before you determine the conjugate, and so on. So you have, the sum and difference, and then multiply the product, multiply them, and then finally you have the division. Okay, so the password for your SEATWORK is, let me just write, is A E M 2 0 2 1. Again, this is the password for your SEATWORK. Okay, you can finish it. The maximum time is 1 hour, but you can actually finish this in less than 30 minutes. Okay, you can use your calculator for checking purposes only. Okay, but for this seat work, you must show your complete solution. Okay, answers must be simplified, and you have to enclose it by, of course, a rectangle. Okay, so submit your output via mrooms. So thank you and have a great day.